Good morning / good evening. Let's get this show on the road. Good morning, Tutu Apps. I appreciate that. Hope you're having a wonderful Friday so far. So for the last couple of days we've been walking around, eventually implementing the water, and have discovered some small tiny problems along the way, and one of them being the grid offset when we don't have any patches. It should be somewhat fixed now, and we should be able to do let's see here, we can add grass, and then if we go water, we can add water as well. And we can see that the grid is now centered, but I noticed that the further away we get from the origin, the more offset we get. So it's a mismatch between the underlying texture and the grid, I think. And I just want to take a quick look at that before we start. If I can't instantly get this to the source of the problem, we might skip it for now. I think we can still debug the water as this. GK, good morning. Hope you're having a wonderful Friday so far as well. And you too, Unscripted Logic. Yeah, welcome. So I'm just gonna check this real quick by doing... We're gonna subdivide once and we're gonna have a resolution of 8. So 8 vertices and 8 pixels in our underlying data texture per in total, I think. So per patch it should be 4 vertices and we can see here that we have 4 vertices. So let's take a look at, I also need to do let's try this. Oh, this grid offset from origin issue math is something I've had way too many times with grid building games. Yeah, and yesterday I felt it. Or I had the same problem rather. Okay, let's take a look at this, and I just want to switch to I want to see the height. Here we go. Yes. Yeah, we can see here that the offset is not quite correct. We want these pixels to be, the middle of the pixel should be at the vertices. Wow, this is actually a way rougher problem than I first anticipated. So I probably want to fix this. Hopefully it won't take too much time as the grid offset from origin issue. Yeah, we have the same problem here. We have the right amount of pixels, we just don't have the right scale. I thought we would have that, so let's take a look at, we can take a look at the I want to do this, terrain debug material. Shader. And the problem then is terrain data texture UV scale and terrain data texture UV offset. Oh yeah, we have them hidden, so let's just show them real quick and see what we're working with. is this... If we're lucky, this could just be a problem with this one not being set correctly. Let's see, what do we have? 128 divided by 8. Now we want to... Yeah, I think we want to scale it by 1 divided by... Or, no, 7 divided by 8, I think. Or 8 divided by 7. 1.14. No, 7 divided by 8. .0. Is this the scale we want to use? And then we want to offset it. No, I think it's 1.14 makes it small, so 0.875. Yeah, I think we want to scale it by this, and then we want to offset it by... Ooh, what do we want to offset it by? Is it half of this one? 0.5, I think. 0.4375. Like, this might very well be... Oh, that's way too much. This might very well be a problem of... just this debug shader being wrong, but I want to, yeah, I want to double check it. Let's see, what should the offset be? It should be, we want to be located around here, or here probably. So the most important part is that a pixel, 4, 5, 6, 7, 8, a pixel, like the vertex should be right in the middle of the pixel. A value of 0.06. What do we get that one from? I think we get it from 8 times 0.5, yes. So this is the offset we want to set. So we want to offset it by 7 divided by 8, or we want to scale it by 7 divided by 8, and we want to do it because we have 8 times 8 vertices, but we actually only have 7 times 7 quads. So we have 7 times 7 quads and 8 times 8 pixels. So we want to scale the UVs by the difference there, and then we want to offset it by half of a pixel width, and in the 8 times 8 texture, a pixel width in UVs are 1 divided by 8, and then 0.5 times that one. Good morning, Geralt, and happy Friday. Should be pretty straightforward. I wonder, terrain data texture UV scale, terrain we don't do it here, we do it in terrain base, I think. Yeah, here we have it. So it's this one, so that's the scale. Currently yeah, Yeah, we definitely want to fix that to... Did I actually calculate that in the incorrect way? That's not good. What did we say? Resolution divided by... Yeah, resolution. I want to replace this one with resolution minus 1 divided by resolution subdivided, I think. I think I have this committed in a... It was previously in a different file. So if my math is correct, let's try it. Resolution subdivided minus 1 divided by resolution subdivided. Is that it? And then when it comes to the UV offset, what did we want to do? 1 divided by resolution times 0.5. So 0.5 times 1 divided by... Yeah, we want to do it times resolution and not resolution minus 1. I just want to check this one. We set it in the terrain material here. But we never set it in the debug material. Is that correct? So my question now, this should be the correct way of doing it. Apps UV scale is like ultraviolet scale, I guess. But in this case, I don't think that's what the abbreviation stands for. And in CoffeeScript you don't use delta. That I don't understand. Couldn't be up to the programmer to use delta if he or she wants. Yes, we definitely want to set these as well in the debug material. I wonder if I'm just going to force it here for now. We don't have it. Okay. Although I am a little bit worried about changing these. Let's see what we get. Like the offset could have been so small that we didn't notice it with grass, or that I didn't notice it with grass. Terrain data texture UV scale 0. That's not good. 7 divided by 8 gives the correct one. Yeah, this one is an integer, this one is an integer. So let's do... This is enough to do this. Yeah, it probably is, but we need to do it in both places. So there we go. So it works for unpatched terrain. Beautiful. Although it looks to be working. And then let's do subdivided. Yes. Fucking amazing. Okay, great. And now I want to check. Let's put this one up to 256 again, and let's go with 0 subdivision. Yes. And then we do it looks beautiful. Absolutely beautiful. And then I want to check. .01 on noise scale. Oh, have we finally fixed it? Possibly. So if we add grass here and then we change to this one, oh, beautiful. Amazing. That is beautiful. And if we add grass or water, I mean. Oh, nice. Okay, now it's just one last thing I wanna see, double check before we jump into implementing the water solver or fluid solver in a recursive way, which scares me a bit. My history with recursive algorithms is a Stack Overflow. Let's just summarize it as that. But I want to check if we still get the correct texture offsets when we run with patches. Looks like it. Okay, this is beautiful. So if we have the height here, what we're gonna do later on is we're gonna change our terraform down to 0.3 and we're gonna change it to terraform height, probably like this, and then we're gonna move down to this one and we're gonna change to water. And the idea is that we add water here. And I don't know exactly how we want to solve it, but we might show each, probably gonna show each iteration per second. So each iteration, we're gonna set each iteration, we're gonna do one iteration each second. Probably want to implement a failsafe as well. So we can see it in real time. Although, let's see here. probably want pixel grid lines here. That would be very nice. So maybe we should start with that. I'm anticipating, like, implementing this water is going... We have a pretty... Let's see here, naive algorithm implementation, or it's going to be, as our first step. And then we might complicate it, make it better in iterations. So it's probably going to be make it work, improve, make it work, improve, make it work, and so on. And during this process, we're going to need to debug a lot of different things. So I'm guessing that the terrain debug visuals will develop in parallel with this water system. And the first thing being here, of course, the first thing being this system, definitely. And we also have this one. But now I would appreciate some pixel lines here. So we want lines between each pixels, because if so we can go to this view and we can easily see each cell, and we can also see the curvature of the terrain, and that's good, I think. So back to the terrain debug shader. What do we have here? Terrain, we should be able to use... Yeah, let's hide these again. I think we should be able to use these ones for it. If we scale... we could probably use this one. We know that this is the offset. Mesh grid lines, mesh grid delta. Yeah, our mesh grid delta lines, they are currently, they visualize the vertex grid, so to speak. So each intersection is at a vertex, and each intersection is actually in the middle of a pixel. So we basically want mesh grid delta, but with an offset, I suppose. We can start by doing terrain data texture UV offset. We know that this one is half a pixel. So yeah, this is where we want to do it. And we can do texture grid color. No, input.uv and terrain texture. This is what we want to use as delta, but we want to use it as 2 times this one. And then the grid width, we're just gonna go with mesh grid width, I think. And can I do this in a nice way without too many repeats? I think we're gonna do it like this. If this one is equals to 1, then return grid color, else we're gonna do something else. So return, let's just do so if it's a grid line, return this color, otherwise we do this. Oh, okay. Yeah, of course. UVs only have X and Y, and we want to set them into the X and Z here. Yeah, that's not perfect. Util helper functions. XZ, that's all we use. Grid delta in world space, grid line with world space. Does it matter? Does it matter? Don't think so. Yes, it does. So what we're seeing here is that we're always getting this one. Terrain data, texture UV offset. Should be equal to 1 divided by 8 in this case. Not 8, but 2, 5, 6. Cannot imagine this one being too big. Okay, we're almost there. Extreme aliasing as well. And we need to offset it as well. Is that the only problem we're having? Something like this, and then we want to just tone down this aliasing a tiny bit. And we're just gonna make it the same way we do here. Alpha, alpha, alpha. View distance in world space. Or we can do let's do it like this, actually. And then we do so we calculate grid color, and then we do return lerp. Just want to double check the order of the arguments here. Access, yes. So we lerp between this color, grid color, and we do it based on grid. And grid is basically just 0/1, I think. I can wait with this one. Still pretty damn rough. Did we actually fix anything? Let's skip. So we get a distance. Grid alpha is 0 if we're close to it. One otherwise. Don't we want to do this the other way around? Yeah, in this case, we want to do it the other way around, I think. But we should be seeing an alpha that is... we're maybe not close enough. Good morning, Desai. What am I missing? View distance in world space. Inverse lerp, so... if you do grid alpha here, one minus this one. So if we're close, we get 1. If we're far away, we get 0. If we're close, we get 1. If we're far away, we get 0. And then we also want to multiply so this is grid alpha. Okay, that's good to know. Would appreciate a little bit more of a gradient, but I will probably take it. Let's see. Still extremely rough. It's like it's binary, and I wonder why. We do grid alpha. Yeah, we return 1 or 0 here. So this one is 1. If it's a grid, then we do this. One if we're close, 0 if we're far away. Extremely rough. It's not that important. I just want it to not alias too much. Still rough. 0.01. Yeah, sometimes we get very bad result, but that's okay for now. Now we just need to offset it as well. We have a little bit of a mismatch going on as well. Although I wonder why. I think we can probably do yeah, but the scale is wrong. I think yeah, in this case we want to do in this case we actually want to do we don't have them shown, but I think in this case now when we want to highlight pixels, then we need to offset it by we want to scale it by... In fact, we just want to scale it by 1, I think. Is that it? Mesh grid delta, however, is in world space, so I wonder if we want to do this. Terrain data texture, terrain data texture. Maybe. And then if we do 1 divided by this one. What's up, Cooler SK? Happy Friday. Yeah, but we're pivoting right now. It's going to be Fight of the Water soon enough. We still have 1, and I know why. We want to do divided by -1, I think. Seriously? To that I'd say wishful thinking. We will see, we will see. What value do we have here? 128. And now it works. Beautiful. Beautiful, beautiful, beautiful. And then we do water. And we do... Oh, that's great. And how does it look if we do... this? Oh, nice. We can check the terraform by this. And then we have water, and then we do 1. So hopefully we will be able to see in a delayed real time when we add water here that it spreads eventually based on amount. Water there. Oh no, it would be beautiful. It's always about grass. Yeah, a lot of grass at least. And my OCD as well. I'm sorry. Okay, so next step. Let's do it. Although, like... it depends on what we draw here. Okay. Something fluid solver. Could SK, for example, how you're gonna handle the grass around the water. We had some different approaches to that. And the cool thing is that water, or the grass, has access to the water amount, which means that we can check if the grass is underwater. If it is, we might change the visuals of it. Yeah, I think we can play around a lot there. What's up, Smack? Now I'm gonna be careful with not saying Smack Gods, Smack GDs. I changed my name, by the way. So do you have... Is it something in your current name? Ah, yeah, I was going to guess that, because you have Smack in both names. What do GDS stand for, if I might ask? If it's not gods. And yeah, as to the progress, it's slowly forward. Game dev simplified. Aight. Someone is angsty with Godot script. Yeah, it could be that as well. Building a brand. Nice. Can we do private void? So this is our entry point to the recursive algorithm. Here we're gonna have the recursive algorithm add so set fluid amount. If I remember correctly, we don't have a check here, but we have the terrain data here, so we know the max and min. It's basically going to be something like this. Set fluid amount, we're going to wait with that one. So here we want to calculate some values, then we want to call this one, and it should be it's going to be something like add fluid to probably gonna go rename this a lot, but add fluid to height. So the idea here is that we send in a height value, and for each pixel we want to take the pixel value and we want to add as much fluid to it so that the pixel itself comes up to the height value. So for instance, let's say that we send in add fluid to height with a height value of, let's go with 0.6. Then within here we're gonna check what is the height value of this one. Okay, so we're gonna add as much fluid as fluid height minus height of the pixel. So that's why I wanna add fluid to fluid surface height. Just fill what the hell? Fill to fluid height. Or just set fluid. What do we have? Fluid surface height. Set fluid surface height. And it's going to be int x, int y, float fluid surface height. Do we need anything else? I don't think so. And what we're gonna do here is we're gonna do terrain data or terrain height is equal to, yeah, we need this one as well. Is equal to terrain data dot get dot raw height x y, and then we get float fluid amount is equal to fluid surface height minus terrain height, and then we do terrain data dot set fluid amount bool set fluid amount x y fluid amount. But we also want to do if terrain height is bigger than or equal to fluid surface height, then we return false. Then we didn't add any fluid here. Otherwise, we calculate the fluid amount and we add it to it. And then comes the interesting part. Now we're gonna call this one 9 times, or 8 times actually, for all the neighbors, and that is going to be the recursive part of it. Is this enough to get us to exit the recursion? That is the question. And actually, I'd like to do this in a coroutine, but we don't have a monobehavior object, so let's once again jump into C# thread. Actually, let's just do it like attribute async await task yield delay. I think we can do this. Private async. Fuck, we want to be careful here. Async and recursive, yeah, that might not be the best match. We're gonna spawn so many threads. Or, yeah, that's the question. Might as well. And hope for the best. What's up, Marcus? Do I wanna... tiny bit scared here, but fuck it, let's do it. What's the worst that can happen? A computer crash, I guess. So what we want to do is delta time task yield working remotely, nice. That's always nice, isn't it? Can we get not yield but wait, milliseconds? Okay, so we want to go 1,000, I think. But what the hell, we can just do nice to be able to watch anything on the side. Indeed, indeed. Fuck, I have to be careful with this one. Very careful, I would say. But what we want to do here then is set fluid surface height, terrain data, x plus 1, y, fluid surface height. We're gonna make this a little bit do we want to do that? No, I don't think we do. Yeah, gonna have to be careful here. Plus, how do we want to do this? Actually, I want to start with, so we go up, and then we go up and to the right. This worries me quite a bit. So recursive function with threading, it's gonna be a shit show, I think, but and then we just want to go right, and then we want to go down to the right, just down and to the left, purely to the left, and finally to the left and up. Haven't worked that much with I'm okay with this. So the idea is we change it for the current, we change the fluid value for the current, then we wait 1 second, then we move on to the neighbors. And for each neighbor we do this, and then we wait 1 second, and then we go on to the neighbors. But. Big question mark is if each of these will. I don't know. Let's see. Okay, do we really want to do? It's gonna be interesting. Yeah, we want to do one more check here as well. If X, we can check terrain data, bounds, inbounds, X and Y. Okay, so if X and Y is not within bounds, then we return false as well. So the first thing we check, are we still in bounds? If not, we return false. Then we get the height of the current pixel. If terrain height is bigger than fluid surface height, then we return false. Otherwise, we calculate the fluid amount, we set the fluid amount, and then we await. And then we prompt all the neighbors to do the same thing, and on it goes. But we not only want to check this, we also want to check float. Let's do it very explicit. So terrain, fluid, surface height is equal to, or I think we want to check terrain height dot fluid surface height. So instead we get fluid surface height, raw height plus fluid amount that's currently active in it. Fuck, we need terrain height as well. So we do the check here on this one instead, because if this one is, yeah, if we already have more fluid or the same in this one, we want to return. Yeah. Marcus, do you work on this full time? No, part time. Yeah, I think Not entirely comfortable with this. I wonder if instead I want to do... I think we're gonna do this. I think we're gonna do it like this instead. We're gonna start a hell of a lot of different coroutines. And yeah, we can't return bool if we do that, i.e. He'll return null. What is it? Is it just return new? Wait for... Guess we can just let it play its course. And then of course we will get an error from this. Does this make sense, or are we gonna crash? Set fluid amount, XY fluid. Yeah. We want to fix this one first of all. And we want to do it like this. Float new terrain fluid surface height is equal to I think we can pretty much be sure here that X and Y here exists within this one. So new terrain fluid surface height is equal to raw height plus fluid amount. Yeah, we wanna do start coroutine. Ooh, I wonder about this. If we enter this one, will we get them filling up one after another? That would be beautiful. Probably. Can you call coroutine without start coroutine? That's my question. If it is a coroutine that enters this method, we can try this. We can try it. But let's see here. So what we do is we calculate the new terrain fluid surface height here by taking the raw height of the start point and add fluid amount to it. And then we start a coroutine that is set a recursive method, set fluid surface height on terrain data, this position, and this is the new height. If it's outside the bounds, we return. Otherwise, we calculate height, or we get height, and we calculate the new terrain fluid surface height for this one, or we get the current fluid surface height. If this one is bigger than the one we got in, we return null. Otherwise, we calculate a fluid amount, that is fluid surface height, minus terrain height. And then we set this fluid amount. Then we wait for a second. And then we go through the neighbors. Yield return start coroutine. Yeah, but what I'm wondering here is that we start a coroutine here. So it's a coroutine running through this one. So when we call this one, will the coroutine adhere to these? Like when we call these the second time, it's actually a coroutine that calls it. Let's just try this. I'm anticipating a crash, but you never know. Let's go down to terraform. Like this. Exciting. We add water. And we want to do it here. And we want to check the water. So height, grass, water. Okay, not the issue. Terrain patch 233. Oh yeah, of course. But I'm gonna do one thing that is gonna simplify the workflow a tiny bit. Terraform. Don't we have brush? Yes, set as additive, change brush strength, change brush mode. Yeah, we need to add a fluid solver to some game object as well. That's for show. So we do this and this. Okay, if the stream goes down now, you know why. Okay, uninteresting. Other coroutines didn't start. You're probably right about that. You're probably right about that. So that was a good call from the start. Let's try it. Okay, now we have exciting times ahead. I wonder... if I really need to get my camera angle in a better position when we are in terraform mode as well. But yeah. And I wonder, what do we want to add here? The fluid amount 0.3. What if we go with 0.5? Is that too much? Ubedev, thank you. I will try and keep that in mind when we move forward. That would be very interesting. I just need to think here. Or handy, I would say. We terraform with minus 0.3. So at most we remove 0.3. Fuck. Let's do 0.4. Okay, hope for the best now. Was 0.4... Okay. Yeah, it was nice. It was very nice. Apart from the fact that I wonder if my values are fucked. Let's try with a smaller value. And it's nice to implement a recursive algorithm with coroutine, honestly, because I noticed now that the further away we went, the longer time it took, right? So would probably have possibly crashed eventually. But let's see, minus 0.3. So what if we add water of 0.1? So water 0.1. Oops. I think it stopped there, but it kept on going. Why is that? Very nice, either way. I wonder, when we create a mesh out of this, would we go... Then we have this point, we have this point. Could we probably... I think this will be very good. 11 caravers, what's up? Ooh, interesting times ahead. I'm just like, when I'm thinking about the steps we're gonna do in this implementation, like every step interests me, like gets me riled up, you know. First of all, the back-end simulation of it, and then when we're going to convert it to meshes, and finally, what I think I'm looking forward to the most, doing the water shader. I've done water shaders before, it's always fun, but this time around we have so much underlying data to utilize in the water shader. Like we can get edge foams based on underlying terrain texture. It's just gonna be incredibly fun. But I think this one kept on going, even though we didn't add any more water. Which sucks. Because I thought we had, if it's outside of the bounds, we return null. If terrain fluid surface height is bigger or equal to fluid surface height, the one we want to add, then we return. Oh, what the yeah. You can't just convert it like that. So we're gonna have to handle this because we're yield return null, but then we're gonna continue there. So in the next frame, we're just gonna continue here. That sucks. UBdev, thank you so much for follow, appreciate it. I want to exit early so bad, but are we gonna have to do it like this? So if this is true, add it here. And then then we want to check this one instead. And then we want to do this. Right. So if we're within bounds, continue. If the terrain fluid surface for the currently checked one is less than this one we add now, then we want to add it, otherwise we just quit. And then we do it like this. So this is how we want to structure it if we do it as a coroutine, right? Like eventually I just need eventually all of this is going to be done in one thread without waiting here, I think. And we're gonna work with Boolean returns for animations and stuff like that, but yeah, that's way down the line. Desai, how are you making sure they don't overlap? Same chord doesn't get watered twice. Every coordinate that is affected by water somehow is going to be visited 8 times, but not more, thanks to this one. So and like, yeah, 8 times, that's costly as fuck, but this is the naive one. Hopefully we can get that down eventually. So if we start with this pixel, we're gonna add water to that one, and then we're gonna move on to all its neighbors, right? So we do this one, this one, and 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 this one. And for each of these, we're going to check all of its neighbors, which means that we're gonna check this one again. And we're gonna do that for all neighbors, which means that this one will actually be visited 8 times plus the initial one. And we do that because it's a naive implementation, but you could also have a case where like this pixel here gets affected by that pixel with a value of 0.3. But then we also have some other pixel out here that goes through the grid. I don't know, some path like this. Maybe we have some river terrain. And it also visits this one, but this one comes with a value of 0.5. So we need to check this one again, because now we want to fill it with 0.5 fluid amount and not 0.3. So the previous value we filled it with is less, which means that we will override it with 0.5. And since it's overridden, we're gonna have to check its neighbors, so then we move in this direction. So the pixel that previously filled this pixel with 0.3 will now be filled with 0.5. But we will only do this, am I thinking about it correctly? Could we have a worst case where we check? Maybe we could. No, I don't think so. So at most 8 times. Yeah, it's a fucking mess. What's up, Fabic? How's the water flowing? I can show you. And hopefully it won't crash this time around. Like, every pixel will always be affected by all of its neighbors, but only of its neighbors. So basically all neighbors can push water, but can it push more than once? Maybe it can actually. Yeah, if we have a very weird terrain setup, we might. We're gonna find out eventually. So let's see here, let's try it again. Water. I would love to remarch it, but it's still a fluid, some type of fluid solver in the end. Do I want to do this? Yeah, we want water. Terraform water, and we add, what did we do? 0.1. And then we quit. Right? No, we don't. Fuck, we need some prints here. We need some prints. Filling position. Can we do debug with percentage? Insertion. Is that something you say? Yeah. Okay, let's see. Something like this, filling position XY with fluid amount. Then just add remark, no weird terrain allowed. Yeah, that's one way to go about it. Now we might actually visit pixels more times than number of neighbors, I think. But I think we can also fix that. Oh, thank you for that link. We'll save it and check it out. After the stream for future use. But I think we can minimize that with sorting these by the actual surface height. So we loop through this fluid solver and we parse it in such a way that we always take the neighbor that will have the highest fluid surface height, maybe. But yeah. Oh, okay, so that's how you do it. So what do we get here? Didn't we? Here, filling 115, 118 with fluid amount 0.09998. Okay, and then we get 115, 19. Okay, so some of them quit. That's good. And what happens then? Then we get... Whoa, we get... a fluid amount. Oh yeah, we're doing... Yeah, we're just filling the same over and over and over and over and over and over. One exit check is not correct. Let's say filling position 115 117. Yeah, we fill it with this fluid amount over and over and over and over again. Okay, good. Just Googled it. Yeah, maybe my Googling skill wasn't the best in the previous prompt. Oh, Unreal Engine and C++. Nice. Yeah, I might join you in the future if the upper level of Unity keeps screwing around. What's up, Peter? This is Unity. Okay, so why do we keep filling that one over and over and over and over? Because this check doesn't complete. How different is C# in the context of Unity compared to C++? I don't think I will be able to answer that one. I haven't done... Like last time I wrote some code in C++ was probably 2018, and I've never done it in the context of Unreal Engine. We set the pixel amount. Yeah, are we getting precision errors with floats here? Possibly. Okay, let's do a cleaner debug log then. Let's see if this works. Filling position, and then we do 0 1 with let's just do we want to do log format as well. And then we do debug.log format. Old value was 0. New value is 1. Terrain fluid surface height and fluid surface height. Yeah. Position, width, amount. Something like that. Old value was 0.34. Yeah, we have a little bit of a floating point error going on. So yeah, that's what we need to fix. We have, I think it's the conversion between C# float or CPU float and texture float. So we need to add a error margin here. Add error margin, and that's what we're gonna do next week, because now I gotta run, unfortunately, but fucking wish I could continue this. I think next week is gonna be hella interesting. Yeah, what's up, Matthias? Oh yeah, we're gonna rely on MathFX procs. We can check that. Beautiful. Yeah, I'm gonna pick this up just where I left it now, on Monday morning, 9 AM Central European time, I think, or just join my Discord to know when, because now unfortunately I need to run. But yeah, as always, thank you so much for watching, everybody, and have a great weekend. Peace.